Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello students. So we are learning the concept of functional dependency since last session. So the concept of functional dependency, we are aware how to prove the functional dependency and how to identify trivial and non-trivial dependencies. And we also solved a few problems which are from class book, workbook, and few questions from gate questions. So we are trying to solve one more question, that is question number 5 of your classroom workbook, which is a gate question which is given in the year of 2015. So this question is also based on functional dependency. So what this question is telling you? He has given some relation with some attributes and some functional dependencies. Now he is asking which of the following is trivial FD. So the answer is PR2ST and PR2R3 and PS2S and PSU2Q. Okay. As I told you how to identify trivial and non-trivial functional dependencies, that is, if RHS is a part of LHS, then it is automatically trivial, otherwise it is a non-trivial functional dependency. So apart from non-trivial and apart from trivial, there is one more dependency by name called semi-non-trivial functional dependency. Otherwise, we can also call it as mixed functional dependency. So once listen, the solution comes like this. We have types of functional dependencies. Two things we know. One is trivial variety we know, and we also know non-trivial variety. And one more variety is there, that is called semi-non-trivial. You can also call it as mixed functional dependency. Okay, we know what is the meaning of a trivial. If RHS is subset to LHS, and non-trivial functional dependencies is if alpha intersection beta is equal to pi. So what is the meaning of semi-non-trivial functional dependency? The meaning of semi-non-trivial functional dependency consists of trivial FD plus non-trivial FD. Okay. So this is how the functional dependencies have been categorized. So we are having types of functional dependencies. which are three varieties. One is a trivial, we know identify. One is a non-trivial, we know how to identify. And one is a semi-trivial, we will be learning how to identify non-trivial functional dependencies. And we know this condition is very well, and we also know this condition is very well. Okay. Once copy the right hand side part so that we will identify what exactly the meaning of semi-non-trivial functional dependency. So that if you know how to identify the semi-non-trivial functional dependency, then from the given list you could easily identify what is a trivial FD. Okay, copy it. Okay, students. So first let us observe what is the concept of semi-non-trivial or mixed functional dependency. Now listen, I am saying, for example, R consists of ABC, right? And I am writing some dependencies. Now we need to identify type of FD in brackets, whether it is a trivial, whether it's a non-trivial, whether it is semi-non-trivial. Okay. So first one, it is very clear. A to A is a what? A to A is what? Since RHS is a part of LHS, it's a blind, goes to trivial. And what is next to one? B tends to B. RHS is a part of LHS, and it is also what? Trivial. Next, AB tends to A. RHS is a part of LHS, and it is also what? Trivial. Next, AB tends to C. RHS is not part of LHS, and it is a what? Non-trivial. BC tends to B. RHS is a part of LHS, hence it is a what? Trivial. See the next variety. AB tends to BC. Now you observe carefully the right hand side. AB is the left hand side. AB is a determinant, but right hand side we have got two combinations. One is this goes to, can you guess? Trivial or non-trivial? It's a trivial because B is a part of LHS. What about C? C is not part of LHS, and this comes under into, yes, non-trivial. Which means The right hand side part consists of two combinations, trivial and non-trivial. Whenever you find this combination, then it is known as what? Semi non-trivial functional dependency. It's very easy to identify. So what is a semi non-trivial functional dependency? Semi non-trivial functional dependency is that if RHS has one trivial and one non-trivial, therefore it is semi non-trivial. That's it. Okay. Now you could get copy the right hand side part, and now we learn how to identify trivial and non-trivial and how to identify semi non-trivial functional dependency. So if you know this, we could easily solve the GATE 2015 question, which is one of your question number 5 of classroom workbook. Okay, copy the right hand side part. So, okay students, now you got copied the right hand side one, and based on that we would like to identify, and we know how to identify whether it fall into trivial or non-trivial or mixed functional dependency. So now, based on the definitions of trivial and non-trivial and semi-non-trivial or mixed functional dependency, now we are able to solve the question number 5 of classroom workbook, which was the question given in GATE 2015. Now tell me, which of the following is a trivial FD? So I'm checking option A. So what is option A? Which is given PR tends to ST. Okay, so PR is a determinant. Now you tell me, S is a part of LHS? No. Hence it comes under into non-trivial. T is a part of PR? No. Hence it comes under non-trivial. So therefore finally it is which FD? Non-trivial FD. Come back to option B, that is PR to RT. Now listen carefully. PR is a determinant, R is a dependent. This R is trivial or non-trivial? Yeah, trivial or non-trivial? It's a trivial because R is a part of LHS. What about T? Trivial or non-trivial? Yes, it is non-trivial. Why? T is not part of LHS. Now, option B consists PR tends to RT. One is a trivial and one is a what? Non-trivial. So this comes under into semi non-trivial FD. Right. Now let us see option C. So what is option C? PS tends to S. Nothing else is given. It's very easily identified. This comes under into PS is a determinant, S is a what? Dependent, and S is a part of what? LHS, and it is a what? Trivial. So directly I can say this is a which FD? Trivial FD. And what about option D? It is given as PSU to Q. So this is completely determinant. Q is what? It's not part of your LHS, and it is what? Non-trivial. So finally, this is which FD? Non-trivial functional dependency. So he asked which of the following is only the trivial FD? The answer is option C. Okay guys, now you copy. Okay guys, so I hope so you completed and you understood the simple logic behind the questions which are discussed so far. So almost all we discussed 5 questions apart from regular examples. So these 5 questions are based on completely rules. The rules are nothing but you need to know what is a trivial rule and what is a non-trivial rule and what is a semi-non-trivial rule. Okay. Now we will continue Armstrong axioms. So whatever dependencies have been proved so far, either trivial or non-trivial or semi-non-trivial, they are all being proved only based on Armstrong axioms. So in the last session, I provided some of the rules of Armstrong axioms. So now in this session, we will conclude them so that the functional dependency topic is going to be completed. So what are the Armstrong axioms are available? As I told you, the Armstrong axioms are also known as functional dependency, inference rules. Okay, as I told you, it is being divided into two varieties: sound rules. Sound rules are also called as basic rules, and the second variety is known as complete rules. These complete rules are known as derived rules. Okay guys, so why they have been called as derived rules? In the sense, because these rules depends upon sound rules. That's why sound rules are basic rules. From basic rules, these rules have been derived. Okay, so what are the basic rules we have? The basic rules we have, the first one is reflexivity. This is also known as reflection. What is a reflection? Let us see the rule first. If alpha superset are equivalent to beta, then alpha gives beta. This is the rule of reflection. So using this rule, you can say what kind of functional dependencies can be derived. That means trivial or non-trivial or semi-non-trivial. So you can easily guess, I can rewrite this condition in such a way: if beta subset are equivalent to alpha and alpha tends to beta, both are same. So what do we understand? This rule tell you what kind of FDs? Trivial FDs. Okay now. So what do we write here? That reflection generates trivial FDs. Right. This is the first property or first basic rule of functional dependency inference rules. Get it, copy. Yeah. Okay, guys. You understood very clearly, I hope so. What is the first basic rule? That is reflection. Reflection only generates always what? Trivial FDs. Now we will see second rule of basic rules or sound rules. The second rule is like this. That is transitivity. Okay. So it is a very easier rule. What is that? If A gives B and B gives C of R of A comma B comma C, then what will happen? A gives what? C. Trivially. Sorry? Transitively. So using this, I could able to get a new production without further rechecking. If A to B and B to C is satisfied, then automatically A tends to C is satisfied. This is the rule number 2. And what is the rule number 3? That is augmentation. So augmentation is nothing but appending attributes. That is the meaning of augmentation. Okay. So what is the meaning of this? Let R of A comma B comma C and the production is A tends to B. Right? So I have taken this non-trivial functional dependency based on AB attributes. Now I have not used C in this functional dependency. So what I do? If attribute C is augmented to A, attribute A, then what is the new production? Then the new production will be like this. So what happened? A to B is given of R of A comma B comma C and C is augmented. C is augmented to attribute A. Therefore, AC gives, already B is there, you drop it. Since you attach C to the left hand side, that C can be attached towards to right hand side. As per as reflection rule. What is the reflection rule? Whatever is there at left hand side, I can write it in right hand side. So here what is happening? Since A tends to B is given of R of A comma B comma C and C is not being involved in the productions, so if I attach C over there, then it becomes AC. Since you have AC with you, I can attach C at the right hand side. So therefore, we get a new production AC to B. This is what? Non-trivial. And AC to C. This is a what? Trivial. So overall this production is what? You know, one trivial, one non-trivial is nothing but, yes, semi non-trivial functional dependency. Okay, so we go once again, one more example. I'm saying A tends to BC of R of ABCD. Find a new FD using augmentation. So you can get answer easily. Why? The D is not involved in the production derivation. So if I attach D at the left hand side, and I can attach D at where? Right hand side. Now the new production is AD towards what? BCD. This is an idea. So by using A tends to B, I could get AC tends to BC. By using A tends to BC, I could get AD tends to BCD. So two productions overall we could obtain from here existing one and a new production, from here existing one and a new production using what? Augmentation rules. Got it? Copy now. Okay students, now you got to understand what's the meaning of transitivity. So transitivity is nothing but by using two production combination I could get another production. Automatically it will be satisfied. For example, x to y and y to z, x to z will be satisfied. And another rule in the sound rules are augmentation. By taking a one production, by appending attributes which are there in the relation towards the left hand side that can be attached to right hand side. So therefore we get multiple number of productions. So we will see one more example based on augmentation. Now see now. I am working with still augmentation only. Yeah. So R of ABCD and the production is given A tends to B. Find a new functional dependencies using augmentation. So the solution, let us append one attribute towards to left hand side, right? So what is the given one? A tends to B is given. What to append? Append C to A. So therefore, what did you get? Tell me. AC tends to BC. This is one production. And let us take once again A tends to B. This time append D to A. Right. And what will happen? Tell me. AD tends to BD. This is a new production. And third one, A tends to B is given. Can you append anything? I am appending this time two attributes to A. So what can I append there? Since the AB is given, now I am appending CD to A. So therefore, I will get ACD tends to BCD. CD right hand side will come. And fourth one, A tends to B is given, append BCD to A. So I could get ABCD tends to BCD. So likewise, you can get multiple number of productions using the concept of augmentation. So ultimately, what do we understand? Augmentation is going to provide furthermore functional dependencies by appending some of the attributes to LHS. So whenever you attach an attribute to LHS, automatically using the reflection rule, that attribute you can also attach to right hand side. So therefore it generates a new functional dependency. So this is how you can derive multiple number of functional dependencies using the combination of augmentation. Okay, now you can get copy that. Okay guys, I hope so. You are very clear now about reflection, transitivity and augmentation. Okay. Now we will see complete rules. Complete rules, also known as derived rules. These rules are derived by sound or basic rules. The first rule is union rule. What is the union rule? It's very simple. These rules are very simple. The union rule is if A gives B and A gives C, then right hand side can be combined. That's it. A tends to BC. This is what is the meaning of union rule. Number two, unionate decomposition rule, which means RHS splitted. So the example is, if reverse to that I am writing A tends to BC, then I can divide this RHS A to B union A to C. This is unionate decomposition rule. And if I am writing one more example, like this, if AB tends to C, then A tends to C and B tends to C. Is it valid decomposition? I will say no, because LHS cannot be splitted. That means this unionate decomposition rule is only for RHS, not for LHS. Is it clear? Now you can copy. Yeah. Okay, students, I hope so. You understood the concept of union rule. The meaning of union rule is nothing but RHS can be combined, and the concept of union decomposition is nothing but RHS can be splitted, but this rule is not applicable for LHS splitting. Got it? And the next one is accumulation. So what is accumulation? Listen carefully. If x tends to yz, observe carefully. If x tends to yz and yz tends to w, then find new FD. What can I write? The solution. You also can guess that accumulation based on transitivity. Accumulation based on transitivity, which means x tends to yz and yz tends to w. Therefore, I can write as x tends to w. It's very simple. A tends to B and B tends to C. I can write A tends to C. In the same way, alpha tends to beta and beta tends to something like theta. Then I can write alpha tends to theta. So since this is the beta and this is the beta, x to yz and yz to w, I can write as x tends to w. This is accumulation. And the last one is pseudo transitivity. What is pseudo transitivity? Listen. I am saying x tends to w and wy tends to z, then find a new functional dependency. The solution is very simple. So pseudo transitivity based on augmentation. Pseudo transitivity based on augmentation. Now you see, let R with x, w, y, z, and this is the production is given to you. Now what I can write is x tends to w. What can I attach? What can I attach? If I attach y to the left hand side, I can attach y to the right hand side. So very simple logic. What I did, I augmented y at the left hand side. Since y is attached at left hand side, that y is attached at the right hand side. So I have used augmentation. So xy tends to wy and wy tends to z. Therefore, what will you get? xy tends to z. This is how you can use the concept of pseudo transitivity. Pseudo transitivity is based on augmentation and transitivity. So attach y to that, so it becomes xy. So xy to wy and wy to z. So therefore you will get xy to z. I hope so you well understood, guys. This is the end of the functional dependency topic, which is there in schema design. So mainly we focused trivial, non-trivial and semi-non-trivial functional dependencies, and we also seen the rules and regulations of functional dependency inference rules known as Armstrong axioms. Thanks for watching us. We'll meet in the next session, attribute closure.